So now we are going to discuss about recurrent neural network. So what is this recurrent neural network? So we discuss about artificial neural network. Then we just discuss about convolutional neural network. Now we are going to start with RNN. That's nothing but recurrent neural network. So this artificial neural network, which is used for regression and classification purpose. This convolutional neural network, which mainly used for computer visions. So this recurrent neural network, which is used for time series analysis. So this ANN is mainly used for regression and classification. For example, either how much your house rate will increase, and this convolutional neural network, which mainly used for vision based analysis. So here we are analyzing about some images, and then RNN, which is mainly used for time series analysis. So we are just having all these things together, ANN, CNN and RNN. So now this is a human image. So in your human brain image, we are having parietal, temporal, frontal and occipital. So this part, which is known as cerebellum, and this is your brainstem, and this is cerebrum. So this cerebrum, this frontal lobe, which is known as RNN, recurrent neural networks. This occipital lobe, which is nothing but CNN, convolutional neural network, and this temporal lobe, this brainstem, that's nothing but our ANN. So when it comes to our neural networks, we are just going to build something which exactly looks like human image. So this RNN, which is for frontal lobe, and this ANN, which is based on the brainstem, and this CNN, which is going to work like a cerebellum. So let's see what is RNN is. So in ANN, we are having an input value, that's nothing but our input layer. Then we are having a hidden layer, which looks like this, and we are having an output value. This is nothing but our output layer. So all our things which we are going to upload to our output values. So your recurrent neural network, which exactly looks like this. So instead of having a multiple input layer like this, we are going to make only one part. So for example, this and this and this. So like this we are going to make some output values. All the combination we are just going to make here. So how this is looks like this, So where our input value, so our hidden or input layer, which is like this, again and again. This is nothing but like our iteration, it will work. So our output value. So this is how our RNN will work, input value and then iteration, and then it will comes with our output value. So this is the multiple recurrent network. So we are going to give a multiple input and we are going to get a multiple output, and this is our iteration, input output iteration, input output iteration, input output iteration. So n number of things, which is known as our recurrent time. So this is our timeline. So this RNN, which mainly used to create our timeline. So this is our timeline. So now our RNN. So this all something how our RNN work. So for example, black and white dog, it's jumping the bar. This is one thing. So for example, only one which is going to jump many. Only one black and white dog which is going to jump the multiple bars. So this is what I meant bar. So this is one too many. Only one dog which is going to jump a multiple bars. So how much time will it take to run? That's what our one too many. And many to one, this is nothing but now we are just going to give a review for something, maybe a movie review or maybe a product review in Amazon or Flipkart. When we are giving a reviews, thanks for a great party at the weekend. We really enjoyed it. So like this. So apart from, we are just going to give lot of reviews. For example, in Book My Show, we are just going to give a lot of reviews. So one person will give some good reviews, someone will give moderate, someone will give bad review. Whatever review is given by the user, which is going to get for only one movie. So for one movie, many reviews. That's what many to one. And many to many, we may just post lot of Facebook. So for example, we are just posting, many of them will post in one page and many of them will view. This many to many best example is YouTube video. Many of them will post and many of them will see. So one to many, only one input, but you are just getting a multiple outputs. So multiple inputs, but you are going to get only one output. So many to many, you are going to get a multiple input and a multiple output. That's what your many to many, many to one, and one to many. So this is how you can able to make our recurrent. So this subspring, which is directed by Oscar Sharp, in this they used to give about this RNN very in depth clearly. So in 1991, this person invented this vanishing gradient problem, which is the main important problem of your deep learning. So this is what, here we are just starting with our gradient problem. So from here it's moving, so up to low and the mid, and again it's going to up. So from here to here and here. So this is what your vanishing gradient problem is. So this problem we are going to calculate based on C. C equal to 1 divided by 2 actual output minus actual predicted input. So WN is your input. This is the rectification. This thing you are going to pass as an another input to another network, and this is the neuron. So output. So this is how our gradient problem will works. So based on this, we are just applying our forward propagation and backward propagation both. So this is the formula which is be applying here. So for this formula is applicable. So the next thing is this WARC, which is nothing but when it comes to small, vanishing, and when it comes to large, exploding. So based on the time, how we are just going to calculate this. That's what our vanishing gradient problem is. So how to explore these problems? So we need to truncate our back propagation. We need to clip our gradients. So this is long-term memory, short-term memory. So in our RNN, everything will stored in temporal memory. So we are going to create a circuit diagram which is going to perform in your temporal memory. So this is how our neural network in recurrent will work. So we are giving a one input which xt minus 1, that's A, and the output ht1, and the output which you are getting, again it's passing as an input, and here from here you are getting one more input. So here we are applying some neurons. So again we are getting one other output. So this is how our recurrent neural network will work. So this long-term short memory will actually work like our normal pipe. The valve increase, the flow also increase like this. This is your long-term short memory model, which is derived from this model only. So we are having a two stuff. One is vector transfer, another one is concatenate or copy. We can able to apply our vector transfer, concatenate, copy, anything we can able to apply. So we need to start your RNN implementation. Simply, instead of making a multiple input layers and multiple hidden layers, you are going to pass one input value to one output value, and the same neuron output, the hidden value output, which we are going to pass again as an input to another network. So this is how your recurrent neural network will work. Now let's apply this recurrent neural network in Python.